Hi everyone, I hope this video finds you well. I am going to be doing a little lesson on inverse functions for you today. And so I have a document that I've created and we're just going to talk through some examples as well as notation regarding inverse functions. So allow me to share my screen and hopefully all of my things are working and we'll get started. Okay, so as you've hopefully already seen throughout the PowerPoint, an inverse function is simply a function whose inputs and outputs are the exact reversal of each other. And so if one function has input of time and output of people, well, then the inverse function would have input of people and output of time. So with regards to the formulas though, and kind of how we manipulate them, if you will, that's kind of what I wanted to talk through today. So I have a function that it's kind of old, but bear with me here, it still gets the point across. We have a function f that models the McDonald's revenue in billions of dollars as a function of the years. The years are defined as y. And as you can see, as it is right now, the input of that function is y, because it's in parentheses is the variable y, and the output is the variable r. And that is true for the function, the original, I should say, function. So if you are wanting the inverse function of that, well, the way that I like to approach it is I first just acknowledge what my original formula is. And for the sake of ease, if you will, I typically temporarily will drop the notation just so that it's not as convoluted. The output is R, the input is Y. This is my formula. Now, the inverse formula for that is to literally invert all of the operations that take place within that function. So this function says that I would multiply the input variable by 1.3 and then add 13.6, and then I get R as my answer. While the inverse relationship is going to do the exact opposite operations such that by the time you're done, Y is all by itself. The letter Y is all by itself. So using inverse operations, we are just going to slowly but surely invert the operations on this function. Now you can't literally take 13.6 away from the variable R. And so we're just going to say R minus 13.6 equals 1.3y. Okay. So then once again, we're trying to get it so that the y is the variable by itself on the outside. So you'll notice right now that y is getting multiplied by 1.3. So the inverse relationship for that is to divide. And now at this stage in the game, you could take 1 and divide it by 1.3 to get a new coefficient of r. And then you could take a negative 13.6 and divide it by 1.3 to get a new value over there. Or quite frankly, you don't have to do that. You can just rewrite it as a giant happy fraction. And now notice at this stage in the game, the letter Y is officially by itself on the outside. So as far as the variable placement, it's exactly inverted now. So if you look at our new formula, the input to that function is now R. And that's the whole point. That's what we wanted. And the output, meaning what this formula solves for, is now Y. And that's exactly what we wanted. So notationally speaking, what we have now is the inverse where R is the input and Y is the output. That is what this formula is. Now you will notice that I did not do what some of your previous teachers might have done. And certainly if you Google, you might see this occur in the online environment. And that is to switch the variables R and Y. Like they literally take the R and they take the Y and they pick them up and they change their places. Folks, don't do that. No, don't do that. It doesn't make sense. Because if you were to just pick up the letter R and pick up the letter Y and switch their places and then rearrange the formula, guys, it would still say R equals when you're done. If you switch the variables and then resolve it, your input and output aren't inverted. The function looks different in terms of the operations. Adding is now subtracting, multiplication is now division, but your variable's in the wrong place. Don't do that. That approach is old school, and it does not make sense contextually. Never, never, never will you see me do that. And I will take points off if you do it, because here's the thing. If you do it that way, you get a totally different final answer and your variables would straight up be incorrect. I'm telling you right now, your variables would straight up be incorrect. Let me do like a quick, just to kind of illustrate my point. How do I just, where's my mouse? Where am I? Oh, I'm way up there. There we go. So if we were to have switched the variables, I'm just going to go through it like kind of quickly so you can see it. So, oops, how do I get my pen? There we go. So R equals 1.3y plus 13.6. So if we were to just switch, why is it highlighting? Who knows? Welcome to teaching online, folks. If we switch the variables, this is what Google will tell you to do. And then rearrange the formula. Going quickly, just to prove my point. Going quickly, just to prove my point. Going quickly. R, divide both sides, do. So the final answer is y minus 13.6 all over 1.3 equals R. Final answer. I'm sorry, what? Look at that with me. R is still the output. It says equals R. That's the same as what it's set up here. That's not proper inverse relationship. No. What in the world are we doing? No. Do not switch the variables. What you're going to do is simply start with the original formula, invert it, yes, using proper inverse order of operations. And then whatever you get as your final answer is simply the final answer. And you will see that the input of the inverse is now what used to be the output, and that the output of the inverse is what used to be on the inside. And that is exactly what we want. Okay. So there's my little spiel, if you will, regarding inverse functions and inverting formulas especially. Now, I just wanted to do a couple table examples just to make sure you guys are comfortable with tables. So we have a table here. It's got X's, F's, and G's. And first thing that I like to acknowledge is just the fact that, yes, you do have 3 columns in this table. And so you've got the X's, and then you've got the F column. And last but not least, of course, you have the, let's see, what color do you, let's go blue. You have the G column. And with regards to inputs and outputs, please don't be weirded out by the fact that it has 3 headers, if you will. Anytime a table has 3 headers, you just want to pay attention to the notation. So you can see that the left-hand side says X. So that is our input. And then F of X and G of X, those are both output notations. And so these are both output functions. It's just that one of them is the output named F, and the other one is the output named G. So when you're looking at part A and it says F of -1, the first thing you need to ask yourself is, well, what the heck is -1? Is -1 an input or an output? And you can use the play on words here to acknowledge that -1, since it's in parentheses, is the input. So you are inputting -1. Okay, but where do you look for that on the table? Well, if you notice how we labeled our columns, this is the input column. So you're looking for a -1 within this column, and sure enough, you're able to find it. Okay, but it's asking me for f of -1. So f of -1 is inquiring what is the output of f at that inputted value. So now this is where the two columns become important. We want to know who the output of f is. So you're going to purposefully pair it up with the output in the f column, not the output in the g column. And the answer to this is -3. Now the next one, g of x equals -3. First and foremost, we just have to identify, well, they're giving me a -3. Why are they giving me a -3? Is that an input or an output? Well, ladies and gentlemen, is it on the inside of the parentheses or is it on the outside of the equal to bar? And it's definitely on the outside of the equal to bar. And that's because it's an output. So the output is -3. Okay, but notice what they want from us on this one is g of what makes -3. That's what we're being asked. What is this guy? What input creates an output -3 in the function called g? So you're looking for a -3, yes, but you're looking for -3 as an output of g. Output of g, that's this column. Is there a -3 as the output of g? Why, yes, there is. But again, what are they asking us? They want to know g of what number, what x value pairs with the output of -3. And so you can see that the number 1 is the x value or the input that pairs with -3 in the g column. So the answer to this one is 1. Or you could also just use notation and say that g of 1 is -3. These are both acceptable. Okay, but that's how you use the table to answer an output column. You have to make sure you're looking at the correct output, because if that said f of x equals -3, well, we'd have a totally different answer. Okay, and then last but not least, this last one uses the inverse notation. So it's very important to me that we talk about that one too. So on this one, it says f inverse of 2. Okay, first and foremost, what is the 2? Well, the 2 is in parentheses. Yes, it is. So it's an input, period. I wasn't lying when I said there's a play on words. If the input is, or I'm sorry, if it's in parentheses, it's the input, period. However, it's an input to the inverse. 2 is the input to the inverse. Okay, look at this table with me. Are any of those columns called inverse? Do you see the little -1 notation on any of those columns? No. So you can't input 2 to the inverse of f when you don't even have a table called inverse f. It's a mismatch. You're like, what am I doing? Am I stuck? Well, you might be, but what you can also try is by definition. By definition, if the number 2 is the input to the inverse, well, then it should also be the output of the original. By definition, the input on one is the output on the other, vice versa. The input on the inverse is the output of the original, etc. Reversibility. So since you don't have any tables called inverse, this acknowledgement is not quite as helpful. Let's see if this new acknowledgement is helpful. The output of, 2, there we go. Can you find an output of 2 for a function named f. Does the table have a function named f in it with an output column? Why, yes, it does. It's right here. So if you can locate a 2 that's an output of f, then you can still complete this problem. So if the output of f is 2, then that means it pairs back up with -3. So the answer to this one, f inverse of 2, is 3. So in terms of how you use the table to answer this one, don't get me wrong. If there was a column called inverse, then I would just be looking for the number 2 that's an input. Same old, same old. 2 was the input. That is what that notation says. 2 was the input. But the only reason I couldn't finish it like that is because then I'd know where to go. I don't have a column called inverse. See, I'm supposed to plug 2 in to the function called inverse, but I don't have a function called inverse. So let's try the reversibility definition instead. And the reversibility definition says, oh, wait a second. What that also means is that 2 would have been the output to f, the original f. And that is right here. And so you can pair it back with the corresponding input. So that is how you answer that one. All right. So hopefully that makes a little bit of sense. Obviously, if you have more questions, just reach out to me or one of our fabulous tutors, and we will continue to hopefully solidify not only what an inverse means, but how to apply that definition to solve either table problems, graphing problems, or formula problems. Thank you guys so much for your time. Hopefully it was helpful, and we will chat soon. Thank you.